Let's talk about precision and uncertainty. Whenever you measure something, the measuring tool that you use has a degree of precision. It also has a degree of uncertainty. So every measurement you take will have some degree of uncertainty. This is true for every single measuring tool, whether it's used to measure the distances between galaxies or the distances between atoms. Every measuring tool has a degree of precision, so every measurement has a degree of uncertainty. When we're looking at a measuring tool and we talk about the precision of it, we're talking about how much do the ticks go up by. What is the smallest increment that the measuring tool can measure? Not the smallest thing, but what is the smallest difference between two different objects that a measuring tool can measure? If I look at my measuring tape here, you can see that the ticks on this go up by 1/16 of an inch. I'm not showing the smallest end of this measuring tape because precision doesn't care about what's down near zero. Precision cares how much do the ticks go up by. To go from here to here is 1/16 of an inch. To go from here to here is also 1/16 of an inch. So the precision of this measuring tape is 1/16 of an inch. I might also have other types of measuring tools. For example, this odometer, which we looked at in the last video, has a precision of 1 mile. That means that this measures to the nearest mile. If I have a measuring tool which measures to the nearest mile, that's great. That might be useful for measuring long distances, but not short distances. This might be great to measure the distance from here to Winnipeg, but it would not be good to measure the distance from me to the camera. So let's look at a couple of terms here. Precision is the smallest increment, the smallest change that your measuring tool can measure. How much do your ticks on your measuring tool go up by? How much do the numbers go up by? You might have a measurement and you need to figure out what would the next number be. That's how much your ticks or your precision is. Your uncertainty is always half of the precision. Once you find the precision, your uncertainty says it's half of that. If I go back and look at my odometer here, the precision would be 1 mile. The next tick would be 592 and 93 and 94. It goes up by 1 mile each time. So the uncertainty here would be half of a mile. I don't know if this odometer is actually reading 119,591.4 or if it had recorded, for example, 90.9, something like that. Because the precision is 1 mile, I might be off by up to a half mile, and that would still result in the same measurement. In this case, that's okay. Being off by half a mile over the lifespan of a car is fine. That's totally acceptable. However, when measuring different things, measuring, for example, the width of a needle used for a medical procedure, being off by half a mile would be a very, very big problem. Let's look at a couple examples here to see how this works. So let's say that we're measuring fabric. If we're trying to measure, or if Susan here is measuring and cutting 2 meters of fabric, and she uses a measuring tape with a precision of 0.1 meters, that tells us something about this measurement. Let's look at this. If she measures 2 meters of fabric, and her precision, so her precision is 0.1 meters, that means that her uncertainty is half of that, 0.1 divided by 2, or 0.05 meters. There's her uncertainty. We can write this measurement including the uncertainty, something we like to call plus or minus form. So I could write the measurement, which is 2 meters, plus or minus the uncertainty. This is a really useful form because it reads as two little math problems. I have 2 meters plus 0.05 meters and 2 meters minus 0.5 meter or 0.05 meters. So if I'm looking for the maximum and minimum length of the fabric, if I were to measure it using a more precise tool, I could go 2 plus 0.05, so 2.05 meters. That might be the maximum. The minimum would be 2 minus 0.05 or 1.95 meters. I just did this as two little math problems to figure that out. This plus minus form here is very important. Put a nice big exclamation point beside that. This plus minus form here is important because this writes it out in a way that's easy to read. This gives us our measurement and it tells us how far we might be off. But notice this is the uncertainty. So if I were to write that in words, I could say this is the measurement plus or minus the uncertainty. So our measurement plus or minus the uncertainty is what I'm looking for here. That is a good format to write this in. Let's look at another example. Let's say that David is building a fence. Okay, he has 3 boards. He needs them to be 6 inches or 6 feet long, and he's attaching them end to end. So if I draw these out here, he's got 3 boards. He's attaching them end to end like that. Each one is supposed to be 6 feet long. So what is the total length supposed to be? Well, the total length should be 6 plus 6 plus 6, or 6 times 3, which is 18 feet. Great. David is using a measuring tape with a precision of 1 inch. So we have to state our uncertainty in this. Our precision is 1 inch. So our uncertainty would be half an inch. You could write this as half an inch or 0.5 inches. Fractions in inches I find easier. So when I write this out, I need to write this out. This measurement here, he measures that board to be 6 feet plus or minus 1/2 inch. So this board might be 6 feet and 1/2 inch, or it might be 5 feet 11.5 inches. All right. When it says state the measurement of all 3 boards, including uncertainty, notice this board here might be off by 1/2 inch. This board might also be off by 1/2 inch. This board might also be off by 1/2 inch. So I might have 6 feet plus or minus 1/2 inch, plus 6 feet plus or minus 1/2 inch, plus 6 feet plus or minus 1/2 inch. When I'm adding all 3 of these up, my measurement is still 18 feet, but because each of these boards might be off by 1/2 inch, I have to add my uncertainties as well. This is important. When you add measurements, you need to add the uncertainties as well. So this here is 18 feet plus or minus 1.5 inches. So if David is trying to fit these 3 boards in a space that is exactly 18 feet, he needs to use a more precise measuring tool. This one would not be precise enough. So this here, the important thing from this example is we need to add the uncertainties. When we add the measurements as well. This is an important step. When we're adding measurements with uncertainties, if I add them up, my measurements get less precise the more of them I have. If I have, say I'm measuring the studs in the wall and there are 18 inches between each stud, if I'm measuring them from one stud to the next, by the time I've got 20 studs across the wall, I might be off by a pretty significant margin. So as I'm adding these uncertainties, I have to be careful with that. Now let's take a look at one more example here. Emily has 2 large beakers. Justify which beaker is more precise when measuring 50 liters of liquid. If I'm trying to measure 50 liters of liquid, well, this would be fairly straightforward because I could use the big container, which has a capacity of 25 liters. I could measure it and use it twice. Or I could use the small container and I could have a capacity of 5 liters and use that 10 times. Notice that the big container is less precise. So let's take a look at how this would actually work here. If I have the 2 containers, my large container has a precision of 5 liters, and it has a precision of 5 liters because its ticks go up by 5 liters. That means that my uncertainty is half that, which would be 2.5 liters. The small container has a precision of 1 liter, which means the uncertainty would be 0.5 liters. Both of these containers have a precision and uncertainty. You may notice this one here is more precise. So if I'm measuring 5 liters, the small container is going to be more precise because it has a smaller precision or greater degree of precision. However, this question says we are measuring 50 liters of liquid. In order to measure 50 liters of liquid, I could use the large container twice. Or I could use the small container 10 times. If I'm using the large container twice, that means that I would need to double my uncertainty. I'm making 2 measurements. I would need to add the uncertainties. So my uncertainty would be 2 times 2.5 liters, which my total uncertainty here would be 5 liters. I would expect if I used the large beaker to measure 50 liters of liquid, I might end up with somewhere between 45 and 55 liters. So I could write this as 50 plus or minus 5 liters. All right, I might be off by 5 liters either direction. With the small container, I need to go 10 times the uncertainty, which is 0.5 liters. So my total is, again, 5 liters. In this case, I have the same thing. I have 50 plus or minus 5 liters. So because both of these measuring tools have different amounts of precision, but I need to use the small container more often, I can actually end up with the same total uncertainty when measuring 50 liters. This is important. This is important. In this case, you might say, well, it's easier to use the big one twice because that way you only have to do it twice. But in this case, you're going to end up with the same precision in either case. I have to add the precision add the uncertainties together every time I use the tool. I used this small container 10 times, or Emily used the small container 10 times. So we have a total of 5 liters of uncertainty here. Hope this has been helpful to help you understand the difference between precision and uncertainty, and we'll see you in the next video.